Hello judges! In this presentation, we'll summarize our robot design, attachment features, game strategy, and program workflow. Our robot's name is Gummy Robo. He comes from a baseline design we used last year with lots of new improvements. He has 2 color sensors, 1 gyro sensor, 2 large motors, and 1 medium motor that connects the gearbox while the other one controls the side wheel. Gummy Robo had to go through design changes this season. We added a gearbox to power the attachments. The caster wheels are revamped to be more stable. A side wheel was added, and wall guides were introduced to reduce frictions on the wall. All of these improvements have evolved a few phases of design changes. Our latest build, Gummy Robo 4, is very sturdy and we use him to complete the missions. A cool feature of Gummy Robo is the front gearbox. It has 2 gear outputs with only 1 worm gear and can produce strong torque for missions.
We created 8 powerful attachments. These pieces, such as the dumper, BFA, duckfoot, blocker, and birdfoot, are designed with extensive tests to obtain best performance. The BFA has 4 pieces: a ramp that knocks down the bench, 2 bars that remove the backrest, a cue dropper that is controlled by 2 triggers, and an M01 and M14 holder. This can easily give us 100 points. The duckfoot is a lift arm design with fingers down and thumbs up. It is used to complete 3 missions in a row, like push down the weight machine, move the row machine tire into the small circle, and lift the basketball hoop to the top. The brilliant blocker is used to hold the pendulum on the step counter so the robot can quickly push it all the way to the end. The delightful dumper is a low-profile, lightweight design and can dump 9 cubes into the boater frame. This design ensures the yellow cube lands exactly in the small target area. The birdfoot is designed with an array of pins used to finish the mission of boater aim and take the blue wheel home. We also designed quite a few other cool attachments for our missions, and we'll use them as secret weapons for future tests.
To decide a game strategy, we first analyzed each mission in detail, then started to prototype the attachments and solve the individual mission. Next, based on the mission difficulty, attachment type, and locations, we tried to combine few missions together. Last, we calculated the scores in the test runs to find the best strategy for a high score. After qualifiers, we decided to improve our score with a new plan and design more attachments for extra missions. After extensive testing, we chose Plan C because it takes the least amount of time. It can finish 14 missions with 3 launches for a target score of 500 points. In Launch 1, our robot is dressed with 4 attachments before the game. The robot will quickly finish M04, M01, M14. And then he navigates to finish M08, aim, and dump 9 cubes into the target area. Next, he takes down the slide figures and brings them home. After, he navigates the tire flip to steal the blue tire. This only takes 50 seconds to get a total score of 170 points. In Launch 2, we finished 5 missions. The robot first travels along the south wall of the complete step counter. Next, he navigates the treadmill, weight machine, row machine, and basketball, and uses 3 attachments to complete them. This gives us a total score of 125 points. In the final launch, the robot pushes the blue tire and dumps a slide figure on the big tire with the super shovel. He then goes under the pull-up bar to knock down the blue cube and boat a share and happily ends the match with a gummy bear dance.
We designed a menu system to control the 3 launches using brick buttons. Each launch is made of a few mission modules. We also created multiple functional My Blocks to modularize our programs and connect each mission during the robot navigation. My Blocks are very efficient to modularize our programs. This helps us to finish a program for a 500-point challenge in a short time. From a baseline Plan A to Plan B, we added 6 extra mission modules for an extra 50 points. In Plan C, we made further improvements. M03 My Block is updated to finish the job 10 seconds faster, and M08 Share is moved to the last launch to save even more time. We made these quick improvements and spent time on testing to achieve the 500 points. Here are some examples of our programs. In Launch 1, it first completes the missions around bench, then navigates to M08 and finishes botch attacks, and completes slides missions. Then it will grab the blobs as well as the blue tire back home. These improvements saved us a total of 16 seconds compared to the baseline solution. In M11, we first align the robot, then spin the side wheel and drive the robot onto the track together. This design enables the robot to repeat missions without error. To ensure accurate positioning and precise navigations, we created a few innovative My Blocks. We combined both reflected light intensity and color mode together for white color detection to make color alignment more accurate. We also made proportional control with the draw sensor to correct the robot's direction when it's off track. We did numerous tests to make sure the draw turn is accurate.
We built our great Gummy Robo with a powerful gearbox to perform awesome tasks. We designed lots of innovative attachments to complete almost all the missions reliably and repeatably. We also created lots of mission modules in our program so we can quickly rearrange them to test new ideas. Another thing is, we challenged ourselves to improve our score to 500 points in just 2 weeks. We are super proud of all of our hard and exciting work.
We also had a lot of fun through the season. We drew funny drawings on the whiteboard to encourage teammates we can't meet in person. We did the pull-up bar with our robot and had a holiday robot dancing party. We celebrate after every successful mission. Thank you!